Hi everyone, I'm Lucía VILLAESCUSA and I'm going to present the work Deciphering Neanderthal Activities, Spatial Statistics Analysis of the Mousterian Lithics Des-Cubierta Cave, Level 3 in Pinilla del Valle. Des-Cubierta Cave is part of the archaeopaleontological complex of Calvero de la Higuera sites, which is situated in the heart of the Iberian Peninsula within the Spanish Central System. The hill is located in the lower part of a tectonic valley surrounded by mountains, as can be seen in this map and in this picture taken from the upper part of the hill. The presence of dolomites and limestones facilitated the development of a multi-level karstic system, which was exploited by hominins and carnivores during the Pleistocene. Thus, several Pleistocene sites have been discovered in the hill, including Camino Cave, Navalmaillo Rock Shelter, Buena Pinta Cave, and Des-Cubierta Cave. Des-Cubierta Cave is the largest among these sites, and it's situated in the uppermost known level of the karstic system. It's an 80-meter-long cave without a roof, with a narrow gallery that measures 2 to 4 meters wide. Its roof was eroded away at the surface of the hill during the second half of the late Pleistocene. Several archaeopaleontological levels have been identified along the gallery, as can be seen in this stratigraphic sequence. And the level 3 was deposited when the roof was still present and during a cold period, according to the pollen and micromammal records, likely during the MIS-4 or the earlier MIS-3, between 70 and 50,000 years ago, more or less. It reaches up to 2 meters in the centralmost part and gradually thins towards the north and the south part of the gallery. The level 3 is a class-supported gravel deposit composed of limestones and angular to subangular dollostones, cobbles, and boulders with a scant matrix. This is the aspect in plan and in section, and these features made it difficult to identify paleosurfaces or sublevels during the fieldwork. Throughout the whole level, the same kind of artifacts were discovered. This deposit contains a Mousterian Lithic assemblage with an archaeofaunal record which is dominated by cranial remains of large ungulates, all of them with defensive appendages. Horns on bisons and aurochs, antlers on cervids, and keratinous horns on rhinoceros. 35 crania of these selected species, some of them clearly anthropically modified, were discovered as shown in this plan. Also, abundant fire-affected materials have been found throughout the level, including rubefacted clasts, barn bones, charcoal, and a barn speleotemic floor, as can be seen in this picture. This record has been recently published as reflecting the symbolic worth of the Neanderthals. Well, with this unusual Neanderthal record, it is crucial to understand the formation processes in order to arrive at correct behavioral interpretations. What we already knew was that debris flow processes were not responsible for the accumulation. On the contrary, the formation's history was characterized by several sealing breakdowns or collapses, resulting in a multi-layered nature of the accumulation. At this point, our goal was to determine if we could identify any variations in the lithic industry within the vertical section, and if the spatial location of the industry could provide insights into different temporal events. For this purpose, we divided the industry assemblage, comprising almost 1,600 pieces, into different types or categories and into raw materials. Regarding the types, we included anvils, cores, flakes, fragments, hammerstones, and safe tools. The bar plot clearly indicates that flakes were the most frequent type, followed by hammerstones. Generally, the raw materials are those present in the surrounding area, and we have divided the assemblage in quartz, gneiss, granite, quartzite, chert, porphyry, and other rocks. And between them, quartz stands out due to its abundance. In the next step, we conducted a point pattern analysis where each artifact was represented as a single point. We generated a multi-type point pattern to analyze the industry by type in the vertical section, and another multi-type point pattern to analyze the industry by raw material. Subsequently, we assessed the intensity using various methods, including kernel density estimation, the scan test, and relative risk maps. Additionally, we studied correlation using the k-cross function, the Mark connection function, and the nearest neighbor count function. We also analyzed the density line in the set coordinate. And what we achieved, well, in the case of the industry divided by types, the density lines in the set coordinates show a similar pattern for flakes, fragments, and shape tools, with 2 peaks at medium and high values of set. In contrast, anvils and hammerstones exhibit a distinct peak around medium altitudes and a smaller peak at low highs. Upon examining the kernel density estimation maps and the scan test, attention is drawn to a high-intensity area of flakes, fragments, and shape tools in the northern and upper parts of the level, as well as a clear concentration of hammerstones at medium elevations. The clearest results for understanding the correlation between different and similar types of lithics were obtained with the nearest neighbor count function, which revealed a significant positive association between anvils and hammerstones. Additionally, flakes tend to cluster together, as do hammerstones. Conversely, a significant negative association was observed between hammerstones and flakes. These findings align with the results of the intensity analysis. In the case of the industry divided by raw materials, the density lines in the set coordinates show more diversity compared to the division by tool types. However, all the raw materials exhibit a peak at medium altitudes, and with quartz also displaying a notable peak at high altitudes. After examining the kernel and scan test maps, a high-intensity area of quartz is evident in the northeastern and highest parts of the level. Granite and gneiss similarly show high-intensity areas in a line around medium highs. Additionally, in medium altitudes, porphyry, quartzite, and other rocks show a concentration of different high-intensity areas. When we examined the results of the nearest neighbor count function, we found a significant positive association between granite and gneiss, as we anticipated based on the density maps. And granite and gneiss and quartz exhibit a tendency to cluster together with themselves. On the other hand, we observed a negative association between quartz and gneiss, quartz and granite, as well as quartz and other rocks, which aligned also with the intensity results. In conclusion, we have identified variations within the vertical section of level 3. At medium elevations, there is a notable presence of anvils, hammerstones, and cores primarily made of granite and gneiss. And in higher altitudes, flakes, fragments, shape tools, and quartz as raw material show high intensity. This may indicate different depositional episodes characterized by the use of different tools and raw materials by Neanderthals. These findings suggest diverse anthropogenic activities occurring at different stages during the use of the gallery. Ongoing analyses are focusing on integrating these findings with the spatial examination of other materials present in the deposit to elucidate Neanderthal activities at the site. This will include the faunal assemblage dominated by these crania, the geological elements such as clasts and boulders, and the fire evidences. And also the use of multivariate spatial analysis could provide a more precise understanding of the temporal events. That's all, and thanks for your attention. Thanks for the organization, and here's my contact in case you want to tell me anything.